Today we shall discuss what we mean by higher derivatives of differentiation. So we have done what is called dy by dx. dy by dx is the first derivative. Now if we say what is the second derivative is the derivative of the derivative. That means d dx of dy by dx. Okay, so this is the second derivative of the first derivative. So this is also written as d2y by dx2. Okay, and we can have much more higher derivatives. That means we can have the third derivative, the fourth derivative, and so on until we can also have the nth derivative. Okay, so this is also denoted by f2 strokes. This is denoted by f1 stroke. This is denoted by f3 strokes, and so on. And this can be denoted f of n. Okay, so this is what we mean by higher derivatives of differentiation. So let's take some examples on the higher derivatives. Okay, fx is equal to x plus 1 by x. So if I say find out the first derivative and find out the second derivative, so it's quite simple. Here f stroke x is 1 plus x to the power minus 1. Okay, sorry, this is fx is equal to, here can be written as x plus x to the power minus 1. So f stroke of x can be written as 1 minus x to the power minus 2. Okay, this is the first derivative. What is the second derivative? Second derivative is the derivative of the first derivative. So now we will find out the derivative with respect to this function. So it will be 0 and this is minus 2. So minus 2 will be multiplied by this will become 2x, and minus 2 minus 1 is minus 3. So the answer is 2x to the power minus 3. So, okay. So this is how we find out the derivatives of derivatives. Okay. Let's say, if we say y is equal to 4x cubed, we can write it this way also. Find dy by dx and find d2y by dx2. Okay. Also show, after we have found out these two, show that 3y times d2y by dx2 minus 2 times dy by dx whole square is equal to 0. Okay, so we have v of y equal to 4x cubed. So we know that dy by dx is equal to 12x squared, and d2y by dx2 is equal to 24x. So let's put the values of dy by dx and put it in this expressions and put it in the expression and see. So 3, what is the value of y? Y is 4x cubed. So we'll write 4x cubed. This is multiplied by d2y. d2y by dx2 is 24x minus 2 into what is dy by dx? 12x squared. So this is 12x squared, and it is a square. Okay, let's see what is it equal to. So this is 3 4 is 12. 12 into 24 is 288 x to the power 4. If you evaluate this, this is 12, 2 this is 144, 12 square is 144, 142 is again 288, and it is x squared squared, so it is x to the 4, which is equal to 0. Okay, hence it's a proved. Hence proved. Okay, let's take another example to find out as an example for higher derivatives. Let's see this one. If y is equal to e to the power ax, find the nth derivative. Nth derivative of y nth derivative of y. It is also written as y to the power n. If we have here y, we can put it into brackets to mean that it is the nth derivative. We want the nth derivative of y. So let's see. So y first stroke will be a e to the power ax, because e to the power x is e to the power x, and the differentiation of ax will be a. So let's see what the second derivative gives us. So again it will be e to the power ax multiplied by a, and this a is already there. So it is a square. What is the third derivative? So here you can see a pattern coming here. So this is a to the power 1 into a to the power x. This is a to the power 2 into a to the power x. Similarly, if we have the third derivative, we will see that this will become a cubed into a to the power x, or a cubed e to the power ax. Okay. So we see that subsequently the power is getting increased by, the power is the same as the power of the derivative. So if we have to extrapolate this, so the nth derivative will be a to the power n e to the power ax. Okay. Let's see if we can have any other example here. Let's say y is equal to sine x plus cosine of x. So prove that y, the second derivative, is equal to minus y. So let's see. So now here we have y is equal to sine x plus cosine of x. So what is the first derivative equal to? It is equal to cosine of x minus sine of x, because the derivative of cosine x is minus sine of x. Now, what is the second derivative now equal to? Cosine x is minus sine of x, and derivative of sine x is cosine of x. Okay, so we can write this as minus outside, and sine x plus cosine of x, which is equal to, since this is equal to y, so it is minus of y, so it is proved. Now, there is another one. Prove that y, first derivative of y whole squared plus y squared equal to 2. This is quite simple. We know that y is cosine of x minus sine of x. This will be whole squared. What is y equal to? Sine of x plus cosine of x whole square. Okay, this is the right hand side. This is the right hand side is equal to this. So let's expand the expression. So this is cosine square x plus sine square x minus 2 sine x cosine of x, plus again here sine square x plus cosine of square x plus 2 sine x cosine of x. Okay, this and this cancel, so we are left with 2 sine square x plus cosine. We know that sine square x plus cosine square x is 1, and sine square x plus cosine square x is 1 from the basic trigonometric identity, which is equal to 2, and hence it is proved. So this is all for today's lecture. Thanks for watching. Until we meet in the next lecture.